Okay, now we're on to the round parts. The Titan 3M, the 5M, and the 6M are all round. So the second, going to use a smaller piece of material, and the other side will be sitting in soft jaws. So now we're going for traditional vice holding on Operation 2 to specific jaws that are shaped the same as this. So this is like your most basic soft jaw type setup. But I'm just going to go over Operation 1, go over some details here. And we need to get into the design portion. So I got edit the setup. I got X and Y in the upper corner, and we're going model box point in the corner. And the material should be 2 by 1, and it says 2.05 long. So I will tell you though, in your setup, a lot of people will cut these on the short side. When it comes to setting up your cutting your material, the 2-inch width is already, that's the bar. The length, which is this way, is going to be determined by the saw. And in the instructions on setup, let me just flip this around. They're telling you to shift this coordinate 25 this way and 20 and 50 thousandths that way. So if this is cut to 2-inch and this is like 1.950, you may not get all material cut. So just pay attention to that part. And we make sure we name, well, I didn't do it on mine. I labeled my program 1001, and I'm going to get this done while I'm here. Titan 3M, Op1, and my initials. All right. Hit OK. All right. If it flips upside down, notice the dot is here. I already have 2 setups. It's like the home view. All right, got the face mill, and we should be using our Titan building block, the STC building block tool. So if I go to here, and I can see right here, these are the old tools. I haven't upgraded mine, but I could do that by pulling the tools out of here. We'll actually have better preset data, but we'll get up to date with that. So on this one, we got the typical face mill top, right? Then we have adaptive going around the outside. And I see this one's got 2 levels. Usually you could do this in 1 level. What I mean by that is, see if I can demonstrate this. I'm going to simulate. So this is the face mill. And then we have this sideways cut. So notice it's not all the way down. So we've been able to cut at full depth. This will work fine. It just takes longer. All right. So some settings in here. I'll see if I can improve this. And I'm going to put in rest machining and stock contours, everything model top. It says model bottom minus 20 and passes. Optimal load is the sideways cutting. That's got nothing to do with the depth. And we got machine cavities, which would be the inside. Slot clearing, climb, maximum step. This is one you want to change right here. Maximum roughing step down. Let's make that 0.8. All right. I'm just going to shrink this up so I can hit the OK button. Let it regenerate. And now it does a full depth cut. Okay. So then you got that. You have the contour milling, this is doing the inside, and the tool is big enough that you really don't have to do a pocket like the bigger parts. If it was bigger, we might have to do pocket to make a nice floor and then do the contour for the walls. This one here is contour outside. You can see right there the tool path. And let's hit contour. Now this is the little tiny tool, the 1/16 flat end mill. This little tiny tool is flat on the bottom. And we're going to use something, it's like spiraling down at the same time. Let's go check that setting. Edit. And we pick the contour. So notice we're picking the blue line right there. And we get the height set. And this one says selection bottom. And this is the face on the bottom with no additional offset. And on this one we have stock to lead, but we're using very small numbers because this groove is almost the size of the tool. So we don't have a lot of room on either side. Alright. And let's look at this other one. Yeah, now we're doing ramp, but we're doing ramp but not as spiraling down the middle. We're ramping but staying in the middle of the slot. So we're changing our angle of attack. So if you did 2 degrees, it would probably take a long time to get down there, but 30 degrees seems to be a pretty good one. And they actually have a maximum step down. So that's like a protection right there. So it's going to spiral down the middle. But you also have to shrink up the lead in and lead outs because you don't have a lot of room. All right. Then you have the two that actually finish the walls. Alright, let's pick geometry on that one. So we're picking this bottom corner right there. So we're machining this wall right there. And let me get the top view here. Top view. I'm just going to go back in and edit. You can see a little bit clearer here. So if you look at this, you notice this is very, very small right there. That's what we call our lead in, lead out. One would be an entry position. I think it'd be a down arrow. There it is. This is going down. You've already cleared it out with that spiral ramp. And it's going to land on the floor. And it's going to actually curve in and then start following that contour. And when it comes out, it'll be back to this intersection and it'll curl out and pull out of there. So that would finish one wall, and then we'll go back and finish the other wall. Okay, so this second one is really a duplicate of the first, only it's the inside wall, that little wall right there. And then we got to do chamfering, but this chamfering, this is pretty simple on the outside and the inside. You can see it right there. You got a big chamfer, big chamfer. This one's actually just going to barely take off the sharp edge of these two corners here. So you could, that would be the second one. And that one you got to play with the numbers a little bit. Got contour selection, you got your heights, model top, using right here, chamfer width, 3/1000ths only. And we have we really don't have a designed chamfer on here, so we just want it to barely touch, and we're controlling how deep we go with the 15/1000ths. That's the tip offset, and this is the picture of how far down it goes. So we're working in a tight area. Then we're going to do our standard spot drilling, which is the drill rapid out, deep hole drilling, see that there, and the taps, which should be not as deep as the drills. Then we're going to flip it over and do side 2. Only side 2 is going to be the center of this part. We shut that one off. So in our setup, edit, stock, we're going to do model, where am I here? Model box point, but we're going to actually pick the center. Well, origin, it's wrong. Box point, and yeah, there they are. Right there, and I got to get the X to go up. I mean the Z to go up. Z-axis. Let's see, Z-axis. There it goes. And flip the X. No, let's just flip Y. Because I have the wrong thing selected here. Oh, there it is. Okay, model box point, and then, nope, that's right there. Yeah, that's where it is, right there. Hit OK. So now we're aligned. So we're going to finish. So the center of this is like the easiest way to do it, is the center of this is going to be our X and Y, and the Z0 will be the top of the finished object. And we'll use our old part setup trick of stealing from the first operation. It says 2.03, so I believe that's actually 0.025. Yeah. Let me go actually look at operation 1. Edit. Setup. Oh, here it is. Relative stock size 50, 50, 25, 25. Okay. Which means did relative size box and add stock to all sides. Okay. We do this one. Relative size box, add stock to all sides, and we got the 50, oops, not 52, 50, 50, 0.025, 0.025. Just gonna okay for a second. Let me get this flipped upside down. Okay. Go back and edit. 50, 50, 25. Oh, this one's incorrect. 0.025, and we're going to put Z plus is going to be 0.23, but Z negative is going to be minus 0.75. Yeah, we got a little square on the top. And then make sure you did your offset, and we're using WCS number 2, which is equal to G55. All right, let me regenerate this one. We got multiple steps again. So we got stock selection is good. We're going to do stock top, except for the bottom has model top. We're going to do multiple depths. 40 thousandths is acceptable, and finishing step of 20. Going both ways, and extend before retract. So that'll take care of the. That's our standard roughing, and so we can steal the 2 chamfering tools. And this one will be chamfer the back, which would be this ring right here. And I did not draw a chamfer, so if I don't draw a chamfer, I have to put a number here. If I have a chamfer driven, then I'll use a 0 here. Alright, and now you can choose to engrave. So I'm actually going to try to do a circular engrave next, but because I haven't done that yet. So I'll talk to you all later.